Okay, so this is the problem. We are trying to find the mean and median. Let me use the doccam. And this is our notes for finding the mean and median. Mean, which is average value of your data. The mean of set of data is the sum of the data value divided by number of values. So first of all, you need to find out the sum of the data value and divide by total number of value, right? So that's the definition. So let's find out the mean first for this particular problem. This is the data, right? And the data is 3, 4, 5, 6, 7, 8, 9, 10, and these are the frequencies. Frequencies means it's a repetition. 3 is appearing two times. 4, test score 4, there are 4 people with 4 score. 5, there are 3 students with 5 score. 6, there is 1. 7, there are 2. 8, there is 1. 9, there are 2. And 10, there are 2. Good. So if you write it like 3, 3, 4, 4, 4, 4, 5, 5, 5, it takes time. That's why they are using frequency table. Yes? And now to find the mean, you have to sum all the data value, divide by the total number of data. So here it's a little bit different. The data value 3 appears 2 times. So you have to add 3 and 3 2 times. Make sense? 4, it appears 4 times. So it is 4 plus 4 plus 4 plus 4. So instead of doing that, you can also find, the multiplication. So I'm going to do that here. To find the mean, I'm going to multiply the data and then frequency. So here, can you see this? Okay. So to find the mean, you can just multiply 3 times 2, right? Plus 4 times 4, plus 5 times 3, plus 6 times 1, plus 7 times 2, plus 8 times 1, plus 9 times 2, right? Plus 10 times 2. That's the data value. Instead of adding 3 2 times, you can also multiply 3 and 2. Is that fine? Yes. Okay. Now you have to divide it by total number of data, and you can find that total number of data by adding these frequencies. You can see these frequencies 2, 4, 3, 1, 2, 1, 2, 2. If you add them all, what do you get? 6, 9, 10, 12, 13, 15, 17. So you have to add this data, this sum by 17. Good? Can you find out this value using your calculator? 3 times 2 plus 4 times 4 plus 5 times 3. And that would be, give me that number. Give me that top one. Say again? 103. Is that right? Okay, the top one is 103. And then bottom one is 17. So if you divide 103 by 17, it would be 6.05. Is that exact number you got, or you are rounding it? 6.058. Okay, while rounding, you have to be careful. Sometime your computer, the problem on computer, they ask you round it to the 2 decimal place, sometimes 3 decimal place, sometimes nothing. So if they, unless they, ask you to have, certain format, you have to follow their direction. Otherwise, you have to give everything. Or you can just round it to the 2 decimal if they don't say anything. Okay? Is that fine? That's your average. So you are going to put that value, for the average here. Good. Here's the thing. The one way you can find this thing is just write down this, the first column, 3, 3, 4, 4, 4, 5, 5, 5, 6, 7, 7, 8, 9, 9, 10, 10. That way you can write your data, right? But instead of giving you this simple small table, if I give you data for, like, let's say thousands of data, then writing that way is very time consuming. Make sense? So we don't do that. So this is the way you have to follow. Make sense? Yeah. Frequency times data plus frequency times data plus frequency times data divide by total number of frequency. That's how you find the average. Good? Let's find out the median for the same data. If you try to find the median, this is the note I give you for finding the median. I'm going to make it bigger. I'm going to read it. The median of a set of data is the value in the middle when the data is in order. So first of all, you have to write down your data in order. Okay? But sometimes your data values, they are, you have a huge number of data. So writing it down manually on paper is not possible. Okay? So you have to use the rule here. To find the median, begin by listing the data in order from smallest to the largest or largest to the smallest. You can go from small to, large or large to small. But you have to have some kind of order. If the number of data values n, here is the number of data values, is odd, then do this. If the number of data value is even, then do this. So there are two different ways to find out the median, and that depends on the number of data values. In this problem, in this particular problem, what is the number of data value here? 17. That's what we found here. The total number of data in this case is 17. Is this odd or even? Odd. If it's odd, what they say here is, if the number of data value n is odd, then the median is the middle data value. This value can be found by rounding n over 2 up to the next whole number. But you can't find just dividing n by 2. That gives you the position, that gives you the location of the data. So in our case, the total number of data is 17, and if you divide this n by 2, which is 17 by 2, what do you get? So 8.5, if you round it to the next whole number, what do you get? 9. So now the answer is not 9. Answer is the position of the data for the median. So you need to pick the data from the 9th position. Make sense? So these are your data, right? And this frequency helps you to find the position. So they are already in order. They are ordering from lower number to higher number. Yes? And then if you add this frequency, they will help you to find this position 9. So initially, first 2 data, they are 3. And then next 4 data, that will be 4. So 2 plus 4 is 6. 6 is already gone. We are interested to find the 9th position. 2 plus 4 is 6. 6 plus 3 is 9. So at 9th position, what do you find? So 5 is your answer for the median. Make sense? So at 9th position, if you add the frequency, you keep adding the frequency unless you get this number. Make sense? So at 9th position, there is a 5. So the answer for this one, the median is 5. Okay, that's only for the odd number of data. If you have even number of data, then what do you do? So if you have even number of data, so then just read it. It says, find the data from n over 2 position and then next position. This n over 2 plus 1 means it's the next position. So n over 2 and n over 2 plus 1. So for example, let's say instead of 17, if you had 18 data, then what would be the n over 2? N over 2 would be divide 18 by 2, which is 9. So you pick the data from 9th position and next position, which is 10th position, right? I'm not talking about this particular problem. If you had even number of data, make sense? So, and finding those data, you repeat the same thing. You start from here, you go up to 9th position, which is 5 in this case, and you find the next position, which is 10th. So at 9 and 10th position, you have 5 for this problem. So you take the average of 5 and 5. Make sense? But this problem does have only odd number of data, not the even number. Is that fine? Did you get it? Okay, so that's how you find the median and mean. So now this is your time. I want you to find out, do the problem 6. You can, you know, do it together or oh. Okay, so let's go back to this thing here. We're trying to find the standard deviation for this data. X stands for the data 28, 14, 8, 21, and 2. These are the data set we have given, and we're going to use this this steps to find the standard deviation. Good. So the first step, find the deviation of each data from the mean. In other words, subtract the mean from the data value. So first of all, to find the standard deviation, you need to find the mean, average. So let's find out the average. What is the mean of this data? The mean of this data is, just add this data, 28 plus 14 plus 8 plus 21 plus 2, divide by total number of data, 1, 2, 3, 4, 5. And what is the mean? 14.6. Don't round it unless they ask you to round it. Don't round anything. To compute the standard deviation, you need everything as it is. Make sense? So that's the mean. If you use X to represent the data, this is the trend. This is how we represent the mean. X bar. X bar stands for mean for that data, average for that data you have given. Clear? Okay. So now we're done with the step 1. We found the average, but still we need to find the difference between average and then data. So we make one table here. We write down the X here and difference between X and X bar. So X is, I'm just copying this data, which is 28, 14, 8, 21, and 2. I'm going to find the difference between this data and X bar. Don't forget that X bar is 14.6, right? So 28 minus 14.6 is, what is that? It's 13.4. Am I right? X means 28, X bar means 14.6. So 28 minus 14.6 is 13.4. And you are going to repeat the same thing for each of them. 14 minus 14.6 is, second, negative 0.6 or 0.6. 8 minus 14.6 is negative, is that 6.6? Okay. 21 minus 14.6, second, it should be 0.4, so that would be 15, so 6.4, right? 2 minus 14.6, negative 12.6. You can also write down this data in order, like from lower to the higher or higher to the lower, but it doesn't matter because you're not trying to find the median. Make sense? So that is our step 1 from here. Find the deviation of each data from the mean. In other words, subtract the mean from the data. That's what we did. Subtract the mean from the data. Are you with me? Okay. What is the next step? Now the next step is square each deviation. The meaning is whatever you got here in the second column, just square that. Meaning is, notation wise, you are squaring the value you have on this column. So what is the 13.4 square? Find out 13.4 square. So you can just 13.4 and then square it. It's 117. It's 179.56, right? Hey, here is the thing, don't round it, because if you round it at this point, then your final answer would be completely different. The standard deviation, if you are trying to find the standard deviation, don't round your answer until the final point. Make sense? So that's 179.56. Let's do the same thing. 0.6 square is, 0.6 square is 0.36, and then square of the negative number is always positive, so you don't have to worry about that negative number. That's 0.36. 6.6 square is, you can always go from fraction to the decimal. It's a 43.56. 6.4 square is 40.96. 12.6 square is 158.76. So these are the square of your deviation. Deviation means x minus x bar. The square of that is, you just have to find out the square of each of these values. And while doing that, don't round your answer. Good? That's your step 2. That's your step 2, square each deviation. That's what we did. Okay. Are you with me? Okay, next step is add the square deviation. You have to add this square deviation. So you just have to add this column. 158.76 is already here, so I'm not going to enter it again. Plus 40.96 plus 43.56. How do you go back? 43.56 plus 0.36 plus 179.56. So if you add them all, it will be 423.2. Make sense? Yes? Okay, sometime we might use this notation for addition, this notation. This is called sigma notation. It means add the value you have given. So for this one, I can also write sigma x minus x bar squared. That means I'm adding that column of x minus x bar squared. Make sense? That is our step 3. If you check your note, you can see that add the square deviation. Say again. Sigma means it's just a notation for that thing, the addition thing. Let's go to the next step. The next step is, after adding, divide by n, which means the total number of data value. If the data represents the whole population, divide by n minus 1 if the data represent a sample. So in this problem, if you check the problem itself, it says a sample was done. A sample was done. So that means this is for sample. This is the sample. Make sense? So for this particular problem, what is the value of n? N means total number of data. 1, 2, 3, 4, 5. So the value of n is 5. But if it's sample, you have to divide by n minus 1, which is 4. So the next step is, to find the standard deviation, you divide this 423.2 by n minus 1, which is 4 in this case because it's a sample. So what is 423.2 divided by 4? It's a 105.8. Good? No. If you check your notes, it says after adding the square deviation, you divide by n minus 1 if you are playing with the sample. And n is total number of data. There are 5 data, so 5 minus 1 is 4. That's why you divide by 4. And that is the number you get. Are we done? So still we have to do something else, and that is the last thing here. Compute the square root of the result. So after finding this 105.8, that's not your final answer. You have to find the square root of this number, which is the square root you can find from this calculator. Here is the square root sign. Square root of your answer, and that is 10.2859. Sometime this is your final answer. This is the standard deviation. Sometime they ask you to round it to the 1 decimal place, sometime 2 decimal place. So just follow the instruction and give the answer. But that's your standard deviation. So the meaning of standard deviation for this problem is, look at here. For this problem, the data is, this is your data, 28, 14, 8, 21, 2. The average is 14.6. In average, most of this data are 10.2859 unit far from the average. That is the meaning of standard deviation. Make sense? Okay, if it makes sense, then let's do the problem 2 together, and that's where you can check the things, you know, how much you